Good morning, everyone, and welcome to our webinar on storage for AI and machine learning. My name is Mike Human. I'm the managing partner at G2M Research. Let me kind of go through the agenda real quick. So I'll give a quick introduction to the topic and talk about some of the ground rules of the webinar. Then each vendor will present for about 10 minutes. We have with us Weka.io, we have with us Accelero, and AIC. So we'll each get about 10 minutes to talk about their views on the space. And then after that, we'll go to the panel discussion. We'll have 3 panel questions that we'll rotate around and ask each of the different people. We also have 2 audience surveys, and you can use the Zoom audience survey polling feature capability to answer those polls and tell us what you know or what you think. Then we'll go into an audience Q&A. And for the Q&A, please use the Zoom Q&A window. You can put in your questions anytime. We'll wait till the end to answer them all, and then we'll do a quick wrap up. And if we go a little long, that's okay. We're not going to cut it off at 10. So, we'll be here to answer the questions reasonably as long as it's needed. Also, this webinar is going to be recorded. Everybody that registered for it will get a link to the recording and a PDF of the slides. You should get those on Thursday. So be looking out for those. We'll send those, like I said, to everybody that registered. With that, let's jump into it. So let's talk a little bit about artificial intelligence storage. So for those of you in the space, I'm sure this is not new news, but AI and ML really have unique storage needs compared to other types of storage applications or storage-centric applications like databases or anything else. The data sets from the learning perspective tend to be extremely large, especially in some of the really big problems. Model validation data sets tend to also be large. On the other hand, the operational data sets oftentimes are not. But making this even more fun is the fact that once you train your algorithms, as we all know, no algorithm's good forever. You have to keep going ahead and updating it and retraining it. And when you do that, it's usually good to hold on to the old validation training data sets and the results from that validation training so you can use those to help improve your analytics and help improve your learning in your modeling. And then finally, the live data lake, or the place where you're keeping your operational data, has to be extremely fast. It has to have a strong connection to those compute resources so you can move data quickly in and out and have your model actually be able to provide you insights in reasonably real time. There's a lot of different architectures that are out there for AI workloads. Most storage vendors that are out there have tried to optimize their different architectures for AI workloads. There's cloud and on-prem solutions. In fact, the cloud guys have made a fairly decent number of strides over time. Though I would still say the large data lake that's really fast can be a challenge for them. But in all cases, you got to have very large, very scalable storage. And it has to be high performance. The slower the storage is, the longer it takes to train a model, which obviously impacts the value of using that model. And then finally, you need to have data management capabilities to store the training data sets and the training results so that you can use those in the future. So here to talk about these topics, we have 3 experts in the space. We have Shimon Ben David. Shimon is the CTO at Weka. We also have Kroll Shoket. Kroll, I'm sorry if I killed your last name there, but Kroll is the chief CTO at Accelero, and then we have AIC. We have Joe Kimpler, and Joe is from the office of the CTO. So 3 guys are really into the trenches on this, really understand it well. And with that, let's go ahead and get started. I'm going to pass it over to Shimon and let you go ahead and get started.
So I wanted to present Weka and definitely the value that it has in AI environments. So first of all, like one word about Weka, our mission is actually to make storage simple, to make storage as simple as any utility and simplify the management while still providing scale and speed. Because we actually see that when moving, scale is very important, speed is very important, and we're going to talk about it, but also the simplicity of management, because there's a lot of on being used that could be improved, and we'll talk about it. So we have actually a very nice list of customers from even the Fortune 50, and 8 of them are actually Weka customers, and we're proud to have a lot of industry-leading investors and partners with Weka. So moving on, what we see is that, as I mentioned, in many environments, obviously the different AI, but what we see is that you can always look at a project as a day one project, start an AI project, and you have maybe you have even a few GPUs in your laptop or in a desktop server that's in your desk, and then as you grow a bit more, GPU servers, and yes, more often they're not nowadays. It's GPU servers, even though there are other. And then day 3, as you grow more, suddenly your environment becomes more complex. You need to manage the data acquisition, retention, and to train an inference on it. And what we see, and this is a typical environment as a project grows larger and larger. So multiple image capturing or data capturing sensors, capturing the data, or even copying the data from where it's needed, centralizing, shared and easy to manage, and the cost makes sense, then definitely copying it to another layer, another parallel file system, or even worse, to the local NVMEs of the GPU servers, simply because the GPU servers, local NVMEs, are considered to be the fastest. And then when there's a requirement to move the data to a longer archive, to a more cost-effective archive, or even DR the data to a different site. So there are different storage environments involved, different processes, different steps, and the reason behind them, if I want to catalog them, is actually different protocols. Sometimes different storage environments are being used simply due to the fact that they accommodate a different protocol, which is required, used due to their performance characteristics. And then other environments are used due to their scalability and price. This is customers to do have an effective environment, but you have multiple different environments that you need to manage. You need to it's very nice to have a day one model that you trained and you can already inference on, but within the life cycle of an AI project, you now have the day 2, day 3 DevOps, where you need to deploy more models, you need to compare them, you need to have the MLOps to accommodate that. So having multiple environments that you need to orchestrate for is actually very cumbersome. So with Weka, that's actually one of the problems that we wanted to tackle, and this is where we see Weka in these environments. So with Weka, we can actually accommodate multiple protocols. So the need to work with different storage environment is protocols is eliminated, because what if you could throw data into the Weka system using any protocol that is actually out there, and if it's positive, them. And more than that, what if the data, not only you could speak with the system in many protocols, but all of the data is shared across multiple protocols. So there's no need to choice. If you could have said, my IoT devices push data into the system on using S3, but then I'm training and inferencing on POSIX or on GPU direct storage, which is also supported. The next barrier, as we mentioned, one was different storage, talking about different protocols, but then the next one is the performance characteristics. So with Weka, we constantly show that even at scale, even at a petabyte scale, the shared Weka environment would outperform the local NVMEs of the GPU server. And I'm going to show a slide or two about it, and that actually shows that there's no need to try to manage the data movement between to another file system or to the local NVMEs of the GPU servers to gain the advantage of performance of training and inferencing on them. So with Weka, actually, you get the shareability of multi-protocol and then the high performance. The extension decision of moving the data to a backup or a DR site. So that actually, again, eliminates the need to have another data mover and another technology. And obviously there is more to that, but I think these are the key factors. So if I could summarize it, if we provide a storage that is multi-protocol, all of the data is shared across all of the different protocols, that you can scale, it would be economic, and it would take the data movement decisions and the data management, which are very critical workloads, then that would provide the best of all breeds. And just summarizing with 1 or 2 slides, in terms of performance characteristics, actually, if I'm concentrating on, we have multiple benchmark numbers showing the hard proof of what I just mentioned about performance. And again, the one thing unique about Weka is that performance is not measured only in throughput. How many gigabytes can we provide? Because frankly, there are a lot of storage environments that are very good at throughput. The very unique thing about Weka is that we provide throughput and IOPS at the same time for the same data sets. So even when, for example, the number of images that can provide, but on the same data set, we could provide 1 million IOPS for the same data set. And we do see that in AI workloads, even though could be that the data that is ingested are large files, developers, data engineers are actually using 4K files, 10K files, or even 0K files. It's kind of like placeholders. So you could have an AI workload that is creating millions of small files. So the ability to provide that intermediate, very unique and very crucial. And I'll summarize with this slide because eventually everything that I just mentioned, especially on the performance side, be accelerated by a Weka environment. And this is a real project that we worked with at the customer before Weka, 80 hours, and that was composed out of the data movers, moving the data to the different tiers, but also computing it. With Weka, it went down to 4 hours. That's a 20x improvement, not a 1 time or 2 time, a 20 times performance. So basically that customer can now do 20. Summarize with that. If there's any questions. So thank you. With that, I'll pass it on.
Thank you much, Shimon. That was great. Let's go now to Krill. Krill is the CTO at Accelero. Krill, I'm handing you control right now.
Okay, excellent. So hi, good morning, afternoon, evening. It's really great to be here. When people talk about AI storage or storage characteristics specific for AI, it's usually presented as a snapshot of pretty large environment. And we happily, enthusiastically discuss pros and cons of each approach, but or each product. But from my experience with customers, it often starts with a small group of researchers that may be already running some experiments and are frustrated that their environment is running slowly, or they would like to expand it. And if and when they are successful, the whole operation can be expanded rather quickly. And this expansion, as I pointed it here, this expansion can take them to a public cloud or two, and then bring them back to on-premises, and or we can introduce issues of data governance, and mobility, and so on and so forth. Uh, what I'd like to stress is that storage for AI is not something very static. It should reflect and support this dynamic environment, and no, and actually this support has two aspects that I wrote presented here. And one of them is flexibility, which is much more obvious, and Shimon actually discussed it in his presentation. But the other one is predictability. And if the model training, when the model is small and you have just a group of researchers, doesn't work on this small scale or is not interactive enough, so why someone will actually extend it to a larger scale just because in order to get the performance they need several petabytes. So this predictability is really unlike many other areas where enterprise storage is used and analyzed. So, as I said, the AI storage should provide both predictability and flexibility and some kind of trade-off between them, some kind of balance between them from the very beginning and along the journey that the customer makes with their solution. So, I mean, some of the real-world AI workloads are really okay and satisfied with large IOs and high bandwidths, and it's really something that it's in practice achieved by many storage products and solutions. However, there are many real-world AI applications that really need low latency and support for millions of small file IOPS to support them. And one of such example is deep learning model training on images or video fragments with even moderate data sets. I'm not talking about large data sets. So the problem is that for these trainings to finish in sufficiently short time, they really need very quick access to a lot of files in order to prevent GPUs from being starved. And the problem of many customers and many researchers that it becomes increasingly harder to get proper information and the distinction between storage products, because you can have so many tricks to hide the latency and real world file operations. And I know that there is there are a lot of the discussions about the relevance of intelligent data management in today's storage for AI. And so what we think that where latency and cost matter, customers are much better served with the divide and conquer approach, where actually some amount of cold object storage is employed for colder data, for like generic data lake, and the really data that is used all the time is put on the on the really fast storage layer. And a trivial example is, for example, one of our larger customers is running machine learning analysis of medical images. So they get a lot of images from hospitals, but these raw images are not what they are running training on. So the images are heavily processed before use, and then the processed images are used for many times. But the original images still need to be stored both for regulation purposes and for the possibility of some new pre-processing in the future. So can these original images be stored on the same Accelero and mesh platform? Yes, for sure, but the cost would be much higher and would be probably prohibitive than storing them on AWS Glacier, for example. On the other hand, could all the images, both processed and original, be stored on one platform with let's say 5x latency of Accelero and mesh? Yes, but then the customer would need to be okay with much longer model training turnaround times, and they are not so. This is just one example, but we have many of them. So in our opinion, there are no shortcuts when latency matters. Actually, one of the question posed by this webinar was the comparison between centralized and disaggregated storage solution. And here I would like to talk about another facet of storage for AI, flexibility or agility of deployment. And here the differences between the centralized or appliance-based approach and the disaggregated software-defined one are the most pronounced. As we stressed the importance of considering the dynamic nature of AI projects, any storage solution needs to scale, and with the projects, and as Michael mentioned in the beginning, AI project may require quite a scale. So while there are scale-out appliances, the maximum scale is often limited, while the software-defined disaggregated solutions like Veco, like Accelero and mesh are natively scalable to very large scales. And another axis is the support for cloud or hybrid deployments. For centralized storage, the only way to properly support such deployment is through a co-located deployments, which are very limiting and have pretty long lead times. And the last topic is similar, but even more striking things, even on premises, the container-ready deployments of centralized appliances are much more limiting than from the mobility perspective than the container native software defined ones. So overall, from this perspective, centralized architectures are more limiting than enabling factor for the AI applications. So why not everyone deploy disaggregated software defined solutions? Because there are many pretty much persistent misconceptions about disaggregated software defined architectures. And here I listed just some of them which we discuss with our potential customers. So first of all, the question of unpredictability of latency, because when you don't have control over the whole architecture, the obvious question is how can you control the latency of your storage architecture? So with Accelerate and Mesh, we have a completely direct application to NVMe data paths, and without any crosstalk on the data path itself, which means we have a very low and predictable latency across deployment platform. Same question about data protection, because you know that storage appliances are provide usually very elaborate data protection options. So we, for example, have distributed mirroring and erasure coding, RAID 6, running between nodes, between racks, and actually tested on clusters of more than 1,000 nodes. Since Accelerate Mesh is a block level solution, and in AI AI projects usually work with file systems. There is the question of integration with various file systems. So we just to make an example with IBM Spectrum Scale, we are reaching over 9 million IOPS in just 2 rack units, and completely fill both 200 gigabit per second and 400 gigabit per second networking with NVIDIA adapters. Setup, which is from the infrastructure perspective, is one of the main questions. We actually on-premises deployment that takes just minutes, while in Kubernetes and public cloud we provided native deployment options. Okay, and just to finish with the illustration of how does this predictability play in the various environments. These are the numbers to a single node on premises or single VM on Azure with NVMe and RDMA drives, or for this matter, single container on Azure with, for example, OpenShift or AKS environments. That's all for me. Thank you.
Thank you much, Carol. Let me hand over control to Joe now. Joe,
Okay.
you should have control at this point.
Okay. Not quite. There we go. Hello, my name is Joe Kimpler, and depending on your time zone, good morning, good afternoon, or good evening. I'd like to thank your time for spending some time with us out of your busy day. You've heard from both Weka and Accelero, and they have great software solutions. Now I'm going to talk about the hardware. It may seem simpler, but it's also very critical. So let me tell you a little bit about AIC, who we are. We're a leading provider of ODM and OEM and COT server and storage solutions. We have in-house mechanical, electrical, system level engineering teams, manufacturing, thermal validation systems. Our products are highly flexible, configurable to any form, standard or custom. We're celebrating our 25th anniversary. We were founded in 1996. Our global headquarters is in Taiwan, and we have offices and operations throughout the United States, Asia, and Europe. So what we do. So the hardware is a very important part of it. If you're looking for high performance NVMe all flash, we have solutions for that. If you have AI, ML, deep learning, GPU servers with FPGAs, we have products that do that. If you're looking for high density, performance optimized storage servers, we have those. Going to the bottom left, if you have network security issues, we have FIPS and NEBS compliant appliances. For hyperconverged systems, we have multi-node servers. And if you need racks, we have everything from a 420U cloud data center solution down to our new 15-inch 1U chassis. So let's talk about, I also did a contrast and comparison for centralized storage characteristics. So from a kind of a storage point of view, if you're running block level data, fiber channel, it's providing you deterministic, in order, lossless delivery on your raw block storage. We love that. It works for you. That's great. The characteristics of centralized storage include one central system. It enables universal communications. It has a presence of a global clock that synchronizes information. It's a consistent system. It can increase your data integrity. It's a single location, and so that includes security, whether it's system, data, or physical. Central location facilities can facilitate the data access and coordination. It can be less expensive to maintain. It reduces the distribution of data, so that reduces redundancy. The data is easily portable in a single location, reduces retrieval time. It does have disadvantages, of course. If there's a catastrophic failure, think flood, tsunami, employee theft, or the system can be destroyed and the data set can be destroyed. A system downtime affects all users, and issues can occur when all users want to access at the same time. So that's just a quick centralized storage characteristics. If you move to the distributed storage characteristics from the hardware side, it's characterized by different systems running individual clocks. It has multiple central units. The advantages of this is that the data is spread across multiple physical locations and can be easily expanded. It can be accessed through many networks and many devices. The multiple locations provides resiliency and the high performance capability of the system because it's spread over the multiple nodes. It does have some disadvantages due to its complexity being distributed. It's difficult to maintain, but if you use systems like Weka and Accelero that can mitigate that, it can increase management costs, again, unless you use those other type of products, and it can be difficult to detect a node that has failed, and it may take longer to rectify it. So for those of you not intimately familiar with distributed and data processing and storage, I made a very simplistic diagram here. If you look at the way we used to do things, the storage would pump up data to the CPU, it'd be processed and back down. Pretty simplistic, but very efficient for what it was used for. As you needed additional compute power, because you had data intensive compute, we added GPUs. So the storage would pump up the data to the CPU and it'd do some processing, it'd pump it up to the GPU. And here the CPU takes on kind of a traffic cop, and it's managing the data as it moves back and forth. But as you start to get to a truly distributed environment, the storage provides data to its most efficient compute. So whether it's a GPU, a CPU, an FPGA, a custom ASIC, or a DPU, a data processing unit, the storage can pump the data to where it's needed most. So if you look at this particular diagram and how you have distributed storage and compute, and you connect it with an NVMe fabric, now what I'm going to give you is a view where the AIC products actually plug into it. So if you look at the all-flash NVMe and you want to do something like computational or in-storage compute, where the actual data is offloaded in SSD and it can actually do some processing there, we have a 36E1S Gen 4 NVMe SSD product. It's powered by AMD EPYC and Intel Xeon processors. It has multiple PCIe Gen 4 and OCP slots. If you're looking to do high density FPGA or GPU, we have a number of products that, again, it has a number of Gen 4 or OCP slots. It's dual Intel Gen 3 scalable processors. You have quite a bit of memory with 32 DDR4 RDIMMs. If you're looking at high performance, hyper-converged compute optimized, we have 2 U4 node units that are AMD and or Xeon powered. It has a plethora of SATA, SAS, whether it's 3.5 or 2.5 storage bays. And we also have tri-mode. Again, it has multiple PCIe by 16 slots for add-ons. If you need ultra high density storage servers, we have 2U 24 bay, 4U 102 bay servers. We also have JBOS and JBODs. You can have front-end compute on those. If you're looking for network security, we have 1U FIPS and NEBS compliant appliances. So FIPS 140-2 is sunsetting September 21st of this year, so it's less than a month away. If you need a FIPS 140-3 compliant appliance, we have it. It's powered by E3 scalable processors. If you need racks and or chassis, our top end is our 420U OCP rack. It has ultra low power, 6-zone smart fans, is toolless, and has Redfish support. Our smallest is the 1U 15-inch depth rack. So what I tried to do here was talk about computational storage, high density storage, hyperconverged, high density storage, and give you products that connect into this network for your solutions. So if there's one slide I want you to remember a month from now, it's this. If you're thinking, why AIC? So we design standard solutions to complex systems. So if you look, we have a full suite of mechanical, electrical engineers and thermal engineering teams. We design everything from a PCBA to enormous test chambers. So if you look at the chamber in your upper right-hand corner, it's over 6 feet tall. Think of a refrigerator, 2 refrigerators by 3 refrigerators with multiple electromechanical devices, as well as thermal zones. Everything's manufactured in Taiwan and not China. We have both the Intel and AMD PCIe Gen 4 platforms. So you can run full 128 PCIe Gen 4 lanes into your solutions. We have complete solutions and we have the ability to uniquely customize them. So say you have Gen 4 and in the future Gen 5 capabilities, we can design riser cards so that you don't have to redesign your motherboard. That saves you time and test and time to revenue. We can customize the BIOS. So if you need individual BIOS customizations, we have access to source code. We have configurability and routability of the PCIe lanes. So with our Max IO technology, you can manage PCIe lanes individually or as a group, and this will help meet your design requirements. We excel at accommodating unique requirements for additional cards like FPGAs, SmartNICs, GPUs, frame grabbers, etc. We have short and small footprint multi-node high density systems. Again, the FIPS and NEBS compliance designs. We have extended life. So a lot of these, you want extended life, 5 to 7 years is typical for us, but we have some that goes out to 10. And one other thing that's unique to AIC is we'll help our partners create customer and awareness demand for their products. So we have a robust social media and webinar network. We can help you get awareness and demand for your products. So for that, I'd like to say thank you for your time. When we think of engineering, design, and world-class manufacturing, think of AIC. My name's Joe Kimpler. If you have any questions, jkimpler@aicipc.com. And with that, I'll turn it over to you, Mike.
Thanks much, Joe. All right, guys, let's go to the panel questions. We'll start off with panel question number 1. We'll have Shimon answer it, then Kroll, then Joe, and we'll rotate the lineup as we go through the questions. So question 1 is, what is the right approach to determine how much storage capacity goes into a particular storage node in an AI ML cluster? And Shimon, we'll start with you.
Great, Mark. Thanks. So great question. So I would state the obvious. So definitely when you have a system that is scaled, the notion of different storage nodes that protect the data across them, you want to size the data per storage node initially, you want to calculate the capacity. So what is the required capacity for your project, or is it multiple projects? So capacity would be the paramount. Then there's definitely the performance needs per that project, and price according to that project. So these would be the 3 main low-hanging fruits that I would size according to.
Excellent. Kroll, what would you like to add to that discussion?
Yeah, we usually talk about balance, and from this perspective, it's really important to balance the storage performance with the network bandwidth. So if you put 24 drives, but only 100 gigabit per second network card, you create clear bottleneck to your storage performance. So since in the disaggregated architecture, number of nodes is less of an issue. From our perspective, we usually recommend to look for a balance between the storage and networking side of the equation.
Excellent. Joe, what do you think on this one?
So it's actually a fairly complex question, but the simple answer is you got to do the math, but that's always not as easy as it sounds. So once you start to pencil out your calculations, you're going to be expanding your answer to not just talk about storage capacity, but key requirements of data access, protection, your retention policy, and that's all part of the equation. So some of the critical factors you want to keep in mind are, what is your current data sets and what's your projected growth rates? What are your data access requirements? Does your RAID data set require RAID protection, and what level of RAID will suffice? That definitely affects your storage. What data retention policies, because you need to provide the right balance between access and protection. And then you can even get into things like in computational storage, but that's getting a little bit down in the weeds. So the bottom line is you have to pencil out your entire system and make sure that you can meet your performance needs. Thank you.
It sounds like not just what you need today, but what you're going to need in at least the reasonable near future as well.
Correct.
Excellent. So let's go to audience survey question number 1. This question is, how big is your largest AI ML storage pool today? This is a check one. Again, I'll launch this. You should see a box pop up where you can fill out your questions. Just go ahead and click them. We'll give you a couple minutes to do that. While we do that, let's go to panel question number 2. And that question is, how do you balance the needs of long-term storage for archived data sets versus data lake storage for training? Crow, we'll start with you for this one, then go to Joe and then to Shimon.
Yeah, for us, it's actually the question is pretty simple because both these quantities are completely disjoint. So you can expand your Accelero storage as you wish, and at the same time, what our customers are using usually some kind of cloud object storage, which also is very flexible. So from my perspective, I would recommend to look for solutions that provide you this flexibility for the development of your project.
Excellent. Joe, what do you recommend on this one?
Well, your data lake architecture is all about storing large amounts of data, which can be structured, semi-structured, or unstructured. You add to that your training requirements. They get into containers, so latency is crucial. So you might think about the use of tiered storage, and this is for long-term capacity and power efficiencies are a key requirement. So you might want to think about tiered storage. Thank you.
And Shimon, what do you guys see from the WECA standpoint on this question?
So it's interesting because, again, I would resort to saying that what we see is that different projects would have different needs. And the different needs are in terms of performance and data mobility and sometimes even regulation. So sometimes you're creating data lakes in regions where you cannot even. So you need to create multiple data lakes in different regions. Sometimes the performance needs or the performance edge that storage can provide is valuable compared to the price that it's added on top, right? So different requirements derive different solutions. But again, I would resort to saying that with as large as needed and expand it on the flight as needed, and my capacity tier is larger needed, and WECA would manage the data movement without needing to involve or complicate the user. Actually really simplifies that and allows you the best agility.
Absolutely true. That does make a big difference. Audience survey question 2. Let's go to that one real quick. And that is, how much cloud storage capacity do you use for AI ML today? Again, we'll go ahead and launch this, give everybody a couple of minutes to fill it out. And while you do, we'll go to question number 3. And that question is, NVMe is clearly the fastest flash storage technology that there is today. Where does it fit in the ecosystem of AI ML storage solutions? Joe, we'll start with you, then go to Shimon, and then finish up with Kirill.
Sure. NVMe SSDs offers AI ML many benefits. Let's use a training of a machine learning model kind of as an example. Machine learning involves a couple different phases. A training model is based on what is learned from the data set and then rerunning the model. So without going too far down the rat hole, this really requires low latency and high bandwidth, and NVMe excels at both those, providing high bandwidth and low latency. For example, the NVMe flash drives can deliver about 1,000 times the performance of HDDs, and it can exceed 5 times the performance of the fastest SATA SSDs in AI training scenarios. So NVMe clearly is one of the best technologies for AI ML. Thank you.
Thank you. Shimon, what do you guys think about NVMe?
So we love NVMEs, right? We based our entire product and architected it around NVMEs as well as being able to communicate with other tiers of storage. But I would say that there's the notion or the initial notion that the NVMe tier should reside on the GPU servers, especially if we're focusing on AI ML use case. We see a lot of customers actually ingesting data from their shared environment to the local GPU servers NVMe tier, simply because their local NVMe solution that would accelerate their AI ML. And that was fairly true. We see that evolving, and with the notions of fast centralized storage environments, we see that actually moving from the servers themselves to a centralized repository where it can be used by multiple components, not by you don't need to copy the data to the specific GPU servers that would train and inference on the data. So it started as local, and then it's moving to be centralized. We actually also see it moving to the cloud, whether it's a private cloud or a hybrid cloud or a public cloud, where some of the workloads are going there as well. So it's actually evolving. And with the new NVMe specifications coming that will actually allow for even more capabilities using the NVMe protocol, there's actually an exciting roadmap for that as well.
Excellent. Crow, what do you think about NVMe and its place in this whole solution?
Yeah, as you see, NVMe is part of an merged name, so it's all NVMe for us. And we think that with NVIDIA buying Mellanox and providing RDNA cards in all the GPU servers, and actually RDNA becoming kind of necessary part of AI environment, NVMe and RDNA together are really allow different different level of performance and latency for AI applications, and you can see it from the development of NVMe interface even for hard drives. So from my perspective, NVMe is from for AI workloads in a couple of years from now, we will be talking solely about NVMe drives, whether they are flash or HDD. And with protocol improvements like GPU direct storage and so on, we see really bright future for NVMe, and especially NVMe and the RDMA combination for the distributed software-defined storages.
Excellent. You know, and I think as Shimon said, I think we're going to see NVMe continue to grow and be used more, and NVMe over Fabric as well. I think will also be a huge part of that. And with that, let's go to Q&A. We only have one Q&A question left, and that question is, does anybody provide a storage controller that can sustain multiple concurrent transactions? Joe, why don't we start with you, and then we can go to Shimon and then to Kirill.
I think there are several companies that do that. Before I get myself in trouble, let me just say, go ahead and contact me at jkempler@aicipc.com. Thank you.
That's a good answer.
I hate to single anybody out and everybody else yells at me.
There you go. Okay, Shimon, what do you have as an answer to that question?
Actually, I would say that in order to truthfully and technically answer that, I would need to understand what you constitute as a transaction, and then definitely what do you mean by saying multiple concurrent transactions. I think that if I'll take it to one direction is, does anyone provide a storage controller that can support multiple different workloads, transactional or not? And the answer is that with Weka, we can definitely do it. But again, to be really technically honest, I'd need to understand the full extent of the question.
I think that's a good answer. Krill, I would assume you'd probably say something similar to that, right?
Yeah, it's very similar to what Shimon answered.
Okay, excellent. And it looks like Mihai has just added in multiple HD streams at a time. So sounds like he's talking about video streams, which is definitely a different problem perhaps than the AI ML side of it. And media streaming is certainly its own unique animal in that respect. But again, I think we have three experts here. If you want to ask them that question offline, they surely are willing to answer it. With that, I think that pretty much wraps it up at this point in time. Again, we are recording this session, and we'll make that recording available to everybody who registered. So be looking for that link around Thursday about this same time. We'll also provide you a PDF of the slide sets. And again, thank you, Joe, Krill, and Shimon for being panelists and helping sponsor this event. And thank you everyone in the audience for participating. Have a great day.
Thank you very much.
Thank
Thanks
you.
a
Make
lot.
it a great day.
Have a nice day. Thank you. Bye-bye.
Bye-bye.